Hello, everyone. My name is Chen. I'm actually like a distinguished engineer from the Huawei Canada. I actually from Canada, so I fly 24 hours all the way down here to talk about one thing, which is TaurusDB. Before we start, let's do a quick survey. How many people actually know TaurusDB? Raise your hand. Wow. Not many, huh? That's exactly why I'm here. So, okay. So let's do a level set, paradigm shift. So if you look back past the 10 or 15 years IT industry, right? So the one thing very clear is actually paradigm shift. People moving away from on-prem database, on-prem to the cloud. There's some couple of data points, right? So Gartner predict by the end of this year, over 85% of global organization will take cloud first strategy, and by 2028, over 70% of the workload will be running in the cloud. And the majority of this workload actually requires some form of the data management capability. So this workload paradigm shift also impact database technology too. So if you look back, right, it's actually happening three phases. So in the early phase, if you look back, right, so the 2010, it's actually initial cloud booming, right? So the cloud vendor actually basically take the open source database, right? Like a MySQL, PostgreSQL, and package it up and running as the services. In this phase, and the cloud vendor actually is focused on the cloud database management capability, right? Basically remove the burden from the database administration. And the second phase we call cloud native phase. So in this phase, basically the cloud vendor actually optimize the cloud database architecture and then make them better suited for the cloud, right? And has better availability, better reliability, and better performance. So the recent phase, which is what we call the cloud native service phase, is happening like 2021. So in this phase, actually, vendor they took the full stack approach and optimized a stack, right? And basically make the services actually more elastic. And then the mainly focus is really move the burden, capacity planning burden from the customer. Okay, so and Huawei Cloud actually went through the same phase too. So we actually started the cloud database services like 9 years ago. Initially, we also took the open source MySQL, PostgreSQL, and also homegrown GaussDB. Right? We packaged up and run in the cloud. So in this picture, actually show a typical deployment, right? So essentially, it's one master, one standby because you need a failover, and also one real replica, right? So all the database service running in the VM and using the block storage, which is a remote storage, right, over the network. So this is typical. You can imagine this essentially is moving the on-prem deployment, the database architecture into the cloud, right? Just using cloud infrastructure. So this is like architecture we're running for a while and realize there's some couple of challenges, right? So the major challenging listed here. I just like a pick 5, right? So the first one is with the storage. Okay, what that mean? That means like because every database instance, you need to have a full copy of data, right? However, the storage are already providing reliability, right, by providing 3 copies. So you can imagine if you have how many instances of database, you're going to have times 3, right? Will be the how many storage. In this case, will be 3 times 3 will be 9, right? 9 copy of data. Second problem, really the write amplification. So what that means is really if you know the traditional relational database, right? The database actually write log and also flash the dirty page into disk. So in the on-prems, those disks is actually local SSD, right? Which is okay, right? But however, in the cloud, everything have to go through network, right? So then once you flash network, and you can imagine each of the instances also have to flash their page over network. That making network become very scarce resource, right? With the resource, network resource, bandwidth. Third one is compute, right? The compute part. Why we're saying that, right? Because you can think about it, right? So the standby and the read replica, they need to keep sitting there and continue replay the log and regenerate a new data, right? Over and over, which consume the CPU, right? And especially standby, you cannot do much. We basically create standby just for the failover purpose. You cannot put the read load on there, right? And then the number 4 will be the slow recovery. It's actually quite easy to understand because like all the log, right? The bin log, especially MySQL, we're using the bin log, logical replication over, right? They have to replay. So the MySQL bin log, as an example, is actually very well-known problem. Is like replay very slow, right? And also, if you have a large transaction, they have to wait until replay everything finish, then you can switch over. That take a long time, right? That's why we talk about like a RTO will be longer, especially have a large transaction. So last one is slow adding a new read replica. I mean, it's also very easy to understand because like imagine you have 10 terabyte database, right? Adding a new replica really means you have to copy the entire 10 terabyte, recreate that 10 terabyte, right? So that takes hours, right? That's why like this is basically the moving the traditional on-prem database architecture into cloud is actually the challenging, right? Okay, so we actually running these services for 1 or 2 years, and we realized this is challenging, right? And then we start this research project, right? Initially, start with research project 2017, right? Took like 2 or 3 years development. Eventually, we officially make it, right? Called TaurusDB. We officially make it public available, I think in 2020. And we basically redesigned the whole database architecture, right, in the cloud, for the cloud. There's a couple of key points, right, I'm going to highlight here. So first one is really the log as a database, right? You probably heard this word, right? What that mean? Remember that in previous slides I talked about like a network is a scarcity resource, right? So we don't want to flash the page over network. And to save the network bandwidth, what we do is like we ship the log over the network, right? And only log flowing to the network, including from compute to storage and between the master and the standby, right? So that basically means the log as a database. Second one we call decouple. So we have two like decouple. One is really compute storage decouple, which is typically people talk about cloud native database is always a compute storage decouple, right? Essentially, so we have a common storage and only have one copy of data, and then all the database instance on top will share the common storage, right? So that's making the compute storage decouple. Second decouple we call log style and the page style decouple. What that means really we actually decouple durability and the availability. So the log style only persists the WL, which is the redo log, right? And then the page style actually is responsible for basically the serving the read and page, only handle availability. So later on, I'm going to talk about why this like a decouple actually have a benefit, right? So, and then the other one is innovation we call NDP. We push down the highway I/O operation from the compute down to the storage node. One good example is like a checkpoint, right? So basically, we don't flash a page over network. We ship log to the storage and let the storage take care of the page reconstruction. Basically, checkpoint will be happening inside the storage node, right? And then the storage layer is actually purpose-built multi-tenant storage, right? And then the cross-AZ deployment, is pay-as-you-go mode. What that means is like you don't need to really, when you create an instance, you don't have to really think about like how much disk space I needed, right? You just come and use, and then pay as you go, right? So you don't have to worry about the capacity planning anymore, right? On the disk side. And then the last one is the compatibility. So the compatibility is very important, right? Because each database ecosystem have their own ecosystem, right? When you're moving your application or the database into cloud, the last thing you want to do is like change your application, right? We preserve that, right? We know that, right? So we actually keep our database is 100% compatible with MySQL in this case. You can think about TaurusDB is like it's a MySQL, but it's better MySQL, right? With all this architecture and technology innovation, what we can achieve end result is like we have 7x performance boost compared with the traditional RDS MySQL, which is a previous slide show, right? It's the traditional moving the traditional database architecture into cloud, right? We have 7x performance boost. And also we have a very low latency replica, right? Because like a lagging is like we can control in the milliseconds level. Right? So this is all wonderful thing, right? So you may wonder how do we compare with our other database, leading database cloud vendor, right? I don't name it, right? I just call it a vendor A, okay? So the vendor A also have their cloud native database, right? Basically, the design principle is similar. It's also log-based database, right? So are we better? Yes, the answer is definitely, right? So we are better in terms of performance, RTO, and also re-replica lagging, right? The reason behind is really, remember in my previous slides I show, right? So we have a log style and page style architecture. So we separate them out. Where the comparator, vendor A, their database architecture, they don't have it. They only have a single storage node, a single storage layer, and which is actually quorum-based, right? Imagine like if you transaction commit, they basically have to parse a log and redistribute to cross the storage node. Then they also need to wait until quorum, right, which is 4 out of 6 to come back. All this heavy lifting work will be in the transaction commit path. That's why like making their performance is worse. Although in our case, we have a log style, right? We separate them out. So when we transaction commit, we actually straight go down to the log style and very quick, right? That's like one of the major reasons why we have a better architecture design, make our performance is actually better than competitor. Some of the test results were actually published in like a single paper, right? So I mean, if you guys are interested, you can take a look. Okay, so this is the basic picture show the TaurusDB single region deployment. The single region we have like a 3 AZ. So compute the storage decouple, and the storage will be deployed in the cross 3 AZ, right? And then each AZ have one copy of data. And then this we basically heavily rely on the storage, handle the replication, reliability. And then you can imagine once you decouple, the computer becomes serious. You can put in the one master on one AZ, and you can start any of number of replica across different AZ. They basically share this common storage layer, right? And because of this compute storage architecture and the reliable storage design, we actually achieve like RPO cross AZ, RPO equal to 0, and a very low latent RTO, which is less than 10 seconds. So we talk about a single region deployment, right? How about the cross region? So in the cross region, essentially we have this regionless DB feature. Some other vendor, let's say vendor A, called global database, right? Essentially same thing, so similar thing. What it does is really handle the use cases two, right? So two use cases. One is really the cross-region disaster recovery. Second one is really basically the near-region data read, right, the case. The technology behind the thing is really we're using the physical replication rather than bin log-based logical replication. So the physical replication, like a replication channel, is very low latency. So we actually can achieve like less than 1 second, right? The replication. What that means, like if one region completely down, right? Your data loss window will be less than 1 second, right? And then we support up to 5 regions total for this regional DB feature. So remember, like previously, when we talked about the old traditional database architecture on the cloud, we talked about the adding read replica take hours, right? Now we look at that case again. So in this case, if you read adding a read replica, so essentially because they share the common storage, you really don't need to replicate data anymore, right? What you need to do is just provision the node and join the existing cluster, everything very quick. So if you don't count the provision time, adding a new read replica actually only takes seconds. And this is the technology and architecture innovation actually enable later on the serverless, right? We can automatically grow the read replica automatically, right? Very quick, adding a new read replica. So the next interesting feature we talk about is like HTAP, right? We actually introduced this feature last year. So the reason behind that is really there's a very clear converging from TP and AP. The TP is the transactional processing, AP is the analytics processing, right? The landscape is converging. So in the traditional database world, right, people tend to separate the TP and AP system out. Then when you have a multiple TP system, when you need to do the deep data analytics, you actually need to set up ETL pipeline, which is very costly and also time-consuming. And most importantly, data freshness is actually a problem because typically take hours, right? Once the TP side, the data get refreshed, the data will show up on the AP side many hours or even days, right? We have a customer, which is some e-commerce, right? The background, right? They come say, okay, they want to do the data analytics, right? In the very fresh data, right? Because that impact their business. So we take that requirement. We actually introduce called Taurus AP cluster or Taurus AP node. What it does is really technology behind the scenes is well known, right? It's a column style vector storage engine, or vector engine, making the complex query super fast, right? Compared with the row style, right? It's like actually 100%, 100 times faster, right? If you run a traditional like against the same query on the row style. What's really the innovation behind is really you just need to click the few button, then you're adding this AP cluster. Once you add it, we set up this low latency data sync channel internally. And it's invisible to you, right? You don't have to do any ETL, anything, right? Then once you do that, whenever your data come in to TP side update, the data will be immediately show up in the AP side in the seconds. So you essentially talk about like we actually can accessing the data in near real time, right? Do the near real time analytics. And the most importantly, the query interface also be like MySQL compatible. So if you're using MySQL, in this case, on the TP side, you can using the query redirectly into the AP node. You get that performance boost and the near real time. So the other interesting feature I'm going to talk about is called hot and cold data separation, right? So why is it interesting? So because this feature inspired from some of our customers, right? When we initially designed Taurus, right? So we have this like a distributed storage, right? And to getting the low latency, the distributed storage will be backed by the local SSD, which is have very low latency, right? Distributed storage, but the costly, right? And then some of our customers actually come to us and say, okay, I don't want to delete my data. I want to keep all the history data, right? But on the other hand, they say, okay, your data storage cost is too high, right? Can you do something about it? So, and then the interesting thing is like those customers, the data they need to keep, but then those code data, once they got graduated code, they don't do the very frequently update. They just from time to time need to query, right? So what we do is really we give them the operation command, right? Let them move the code data into object store, right? Essentially, you think about this, offload some of their code data to the object store, which is like a very long-term, cheap storage, doable storage, right? And then we providing the unified query interface and allow them to query the data from both hot data, which is sitting on the distributed storage, which is backed by SSD, and the code data on the long-term object store. And everything will be transparent to them, right? And even better, so we did this operation not on the master, because we don't want to impact the master operations. We actually did that on the real replica. So that's like a less impact and the low cost and achieve the a customer requirement, right? So this is basically the feature we make it available end of last year, okay? So last thing I want to talk about the serverless, right? Remember the paradigm shift from the cloud database, cloud management to cloud native database. Last paradigm will be the serverless. In the serverless, Taurus actually right now providing two modes. One is called reserved mode, the other one called serverless mode. The serverless mode is very suitable for this dynamic application, right? What that means your workload have like a peak and valley, right? Some customer like e-commerce, IoT, even like electronic car maker, right? They have this workload pattern. So if you have very stable workload, right, you don't need to think about the serverless at all, right? You just go straight to the reserve mode, right? That's probably better suited for you, right? In the serverless mode, there's a couple like a challenge, right? So if you actually provision for the average workload, then you need to worry about when the workload is going to peak, I need to resize it, right? I mean, imagine if you want managing like only one instance of database, it's probably okay. But if you're managing fleet of instance, right, that'll be like a really painful process. So the serverless mode actually take care of that, right? Basically, we actually take care of watching the workload, application workload demanding, and we dynamic adjust the resource, right, for you. And then you just don't need to think about the capacity planning anymore, right? And we take care of that. So how do we achieve it, right? So we have this entire full stack of intelligent serverless architecture. So there's a couple of the key technology there. So from the resource detection and the workload detection and the resource adjustment, we can done in the seconds. And then the second one is really the granularity, right? So the granularity, like here, we actually support 0.5 TCU. What that means TCU is like an internal resource unit, right? 1 TCU equal to essentially 1 vCPU, 2 gig. 0.5 TCU equivalent to 1 gig, basically, right? So when we adjust the resource, that's our step, okay? So next thing is for the application scalability, right? Because when we resize the instance of database, we do both. We do like a vertical resize and also horizontal resize. When we do the vertical resize, eventually the local physical resource may have a limit, right? You hit a wall. When that happens, you have to do the switchover, right? But then switchover may impact your application. You may have to lose the connection, right? Retry. This is really painful. So we actually introduced the called Outer, the application lossless transparency technology to help you do that, right? Essentially, the internally is actually a proxy layer to bridge the application and also the database instance, right? In this layer, we do basically maintain the connection when you do the switchover. We also do the rewrite split, right? Making adding read replica also transparent to the application too. So So overall, for the like a full serverless stack, we can support one master and multiple replica up to 100 of the virtual CPU for one single database, like a Taurus database instance. Okay, so let's look at one customer example, right, who actually benefit this technology. So StarZ Play is a number 2 OTT platform, like a vendor, right, in the Middle East. So they actually are serving, like providing over 400 of the live channel and also VOD to 3.2 million users across 19 countries. So you can think about like they actually just basically do the video, right? They have this very typical peak value workload pattern, right? Which makes sense, right? Because I mean nobody really sitting there watching TV for 24 hours, right? So they're actually looking for this serverless solution. Initially, they actually go to the vendor A, right? And using their solution for quite a while, right? But then after a while, they realize there's some continual challenging for them. I just named a couple of them, right? The first one is really the vendor A server solution. They don't have basically the outer technology or proxy layer. So which customer have to managing this rewrite split on the application layer. And then this adding a pain because when they like need to adding a more replica, right? So then they have to adjust manually, right? This is a very painful process. And second one is really the performance. They find out when they adding more results, performance didn't really increase for whatever reason, right? The last one is also a problem for them is really when the workload are going to valley, they find out actually the vendor A solution take a very long time to shrink down the results, which they have to pay. so the end result, they come to us about 1 year ago, right? They do the POC, and because the technology I mentioned previously, we're actually addressing them perfectly, right? So after 1 year, they become very happy customer. Okay, so let's see a serverless demo. I mean, this is a record demo, right? So let's try. So this is Huawei Cloud. Let's see, we first create a Taurus instance serverless. We select a min, max, and also define how many replica we can add it. So the Taurus service instance are created, right? The minimum is a 2U, maximum can grow to 16U. And initially, it's actually, you don't have workload, right? That's why like CPU and memory is very low. And instance has been created. So now we switch and running sysbatch. Sysbatch is like the MySQL very famous benchmark. We start to adding a pressure on the database, right? And initially it's like about 40,000 of the QPS. And then this is we skip some step, right? So essentially like we can see the instance actually growing from 2U to 16U for master and the replica. Basically, initially it's 2U, and then automatically growing to 16U. And then the QPS is actually growing. When we actually increase the results, the QPS also get boost. And now we continue adding the pressure, right? So now the system realized, okay, it's enough, results is not enough, right? So I have to adding a provision new replica automatically behind the scene, so adding a new replica here. It's actually scale out the read. Right? So now the replica actually added, because we have this layered proxy layer, the application is transparent, and then basically spread out the load, right, to the reload to the replica. So when we're adding a new replica, initially it's starting from AU. That's like a basic design policy. Then once we load going up, eventually we're going to 16U. So now let's stop the performance test, right? Assume they're going to down the valley, right? There's no workload anymore. And then the system actually monitor that I mean, after for a while, they actually shrink down all the instances from 16U to 2U. Eventually, and then after for a while, and they realize, oh, there's a continual no more workload, then they automatically release the replica. Okay. So highly condensed video. Okay. Okay. So yeah. So this is basically the demo. So you may actually this is very wonderful technology, right? You may ask when can I use it in Thailand? So I'm happy to announce TaurusDB serverless official launch in Thailand today. Thank you.